Today's program is Kaprekar number. This is quite interesting program. What Kaprekar is basically sum of a square of the number separated into two halves is equals to number. So we have the program. We have two programs in fact. One is 100% right and the other is a bit wrong. Like this one breaks in very extreme conditions, and if you are interested in the right program that will never break, this is the one. So hi, I'm CGR, welcome to Education Value. Today we have another amazing video on the Java program, so let's do it. So first we'll give the simple program for Kaprekar number. After that we will see in which case it will break and what to do if it does and if you want that. Okay, so let's start with Kaprekar number. Sum of square of number separated into two halves equal to the number. For example, 45 and 297. So 297 is square. It is separated into two halves using modulus and division, and then the quotient and remainder is added back and it gives the original number 297. So it is very straightforward. And there is also a point that no half of the number is 0. For example, in 10, if you like square it will be 100, and 10 plus 0 is equals to 10, but it is not a Kaprekar number. There is just one clause, PS, no half is 0. Okay, so example, which we take 297, we squared it, 88209. 88 plus 209 is 297. How we divided the number? Using the simple maths. We had to remove 3 digits, so we took 1, 2, 3. 3, how we took 3? We took 3 on the basis of number of digits in the original number. So 1, 2, 3, length was 3, so we took 3 zeros and we divided, so we got 209. And of course the other half will have 88. So that's how we did it. So this is the program. Enter the range of number, system.out println, enter the number from this range. We took the number, we do the reverse checking. If the number is incorrect, it is not in range. Else, when it is correct, we proceed to the else loop and we proceed with checking of the program if it is a Kaprekar number or not. So we squared it first of all, then we convert the Integer.toString. We convert the number which is n to the string. Why do we convert it into string? This is the best way to find the length of the number generally in just 2 lines. So we find the length of the number. After that, we have the square here. We use a square. Like you don't know what will be the length of the number. So like you don't know what will be the length of the number. So how many zeros has to be there? So since you don't know that, we have to use math.pow to add those number of zeros at the end, like make 10 multiples of 10 in that order so that it divides the number correctly almost. So when we use modulus to get the second half, modulus gives us the second half, and it doesn't matter, second half, and division gives us the first half. So first plus second is equals to n, and first is greater than 0 and second is greater than 0, then it is a Kaprekar number. Otherwise it is not a Kaprekar number. This is very straightforward program. You just take the input, square it, find its length, get math.pow to create 1000 in this case, and after that you convert. Of course, math.pow gives the result in decimals, so we convert it into integer. After that, the whole uses it to divide the square of the number and modulus the square of the number and divide the square of the number. It gives the first part and the second part. Okay, first part, second part. This is the model what we use using math.pow 10 comma 3 in this case. And if the checking is right, if both number are greater than 0 and first plus second is equals to n, system.out.println, it is a Kaprekar number, else it is not a Kaprekar number. Pretty straightforward. Okay, this seems very simple, but there is one issue. This program breaks in extreme condition. By which I mean, in this example, for example, in this example, it may break in even more numbers, which is very rare, but it will break. So if your teacher is like giving you this program and if you want to make fun of him, kind of, so you can use this number to break this program. Okay, so why does this program break? Because the definition of Kaprekar number is separated into two halves equals to the number. Separated into two halves equals to the number. We are not separating it in, we are not checking if all the halves. So for any number, we can divide it into many halves, not just like we can divide it by into two halves, or we can have one side can have 3 digits or 4 digits or 5 digits. For example, just for an example sake, we can have it in like 804641 and the other half is 23. We can have like one part is 203 and other part is 04614. So in this case, in this example, if we take the square, which is 2080461, and if we divided it using the normal case what we were doing, like it has 4, so it will remove last 4 digits. So last 4 digits won't give us so when we will add the last 4 digit with the first 4 digit, it will of course 456, it will cross 456, it will cross 7000 approx. So it will not be equal to the number. But if we see that if we take the first 3 digit and last 5 digit, then it will give us back the number. So it is still a Kaprekar number. But here in our case, in this program, it will break the program because it will show it is not a Kaprekar number, because it will add 2380 plus 4641. But it is wrong. But it doesn't break in most other numbers till 10,000. It doesn't break till 10,000, but only breaks in 4879. So it is theoretically correct program, but it is not the ideal correct program. So how to go about it? This is the program to go about it. Use substrings. So we will loop from starting to last, and we keep forming two numbers using substring. One number will have 2 first, other will have 380461, and then we will have 23, and then other will have the green part, and then we will have 238, and the other will have 0461641, whatever. We will go through whole of it. How will we go? We will go use substrings to extract this part of the numbers and substring to extract the other half of the number, and then we will check both halves. If sum of any of those halves are greater is equals to the original number, it will be a Kaprekar number. So that's what is the logic behind this number. So we again take input in the range, enter range of numbers, enter number in the range. We again take the same not in range reverse checking. After that, we take the square of the number, we convert the number into str string, like we convert it into a string, we convert the original number into string, we convert square into string. We are using boolean to keep if it's true or false, if it is a Kaprekar number or not. We could have also used any number and made it 0 or 1 and then check it, but why not use boolean as well? So left part, so substring. So for substring, you have to understand that it takes, in the substring program, you substring 0i will, the substring formula. Okay, so I will tell you about the substring formula. Substring, if it is a and b, so it will take from a to b minus 1, and if it's only b, so it will take from b to the end of the program. Okay, so here it is 0 and I, so it will take from 0 to I minus 1, and if it is substring I, it will take from I to the end of the number. That's how substring, end of the string, that's how substrings work. Substring is used to extract part of the string. So str.substring, it will render a string. After that we convert it into integer. We can also use integer.value of, but we are using integer.parseString here, doesn't matter. Then we extract the left part, which is 0 to I minus 1. Like I gives you until minus 1, and the other I will extract from I to end. Okay, so first is 1, so it will extract only the 0th position. After, and the other part will have all from I is 1. In computer program, 2 3 4 5 6 7 1 2 3 4 5 6 7 8. Okay, so it will be 7 in computer program. In computer program, we start from 0 and we go to the n minus 1 character. So first is 0th character, so we have to take first as I. 4 5 6 7 8. Okay, perfect. So first is the 0th character, so we take the first, we enter in the for loop first I as 1, so it will take only second. After the, and from it will start from 1 and take till 7. After that the loop moves to the second one, so it takes the value of I is 2. The value of I is 2. Since the value of I is 2, it takes 2 and 3, and it will, it is the second position, so value of I is 2, so it takes 2 and 3, and the right part is 804641. Then the cursor moves to the third position, so I minus 1, I minus 1 238, and the other part is 04641 238 04641, this part. So this time it will be true, it is a Kaprekar number. Left part is greater than 0, right part is greater than 0, and Kaprekar number will be true. If it is true, it just breaks and prints. Is if a Kaprekar number, it checks it's true, so it prints and is a Kaprekar number, else it is not a Kaprekar number, we close the loop. So that's how we do Kaprekar number checking. These two are the programs. One we use math.pow to make the thousands, like in the multiples of 100, and get to that whichever number of the digits are there in our original number, we separate out based on that, and it breaks into, in one example it breaks down, so for that we can use substring, whichever you like. So I will run both of the programs to check if like it. I have already checked, but yeah, let's do it once more. So input range of number 1 and 300. We enter 297, enter. It is a Kaprekar number. Good. And the other one we enter, and this is the other one, so we'll enter the other number. Then I will show you that it gives wrong input in this number. 5,04879. Okay, it is a Kaprekar number, but in the first one, like, we can try any other number, it will not break, but only in the range 5,04879. It is not a Kaprekar number. This is one where it breaks. I have checked for all the numbers. Okay, so this was a program checking Kaprekar number. Thank you.